Hello there, this is exercise 16E. We're going to look at outliers. And an outlier, we're going to need to know what one is, and we're also going to need to know what to do with it. And this picture up here is trying to show you one of our rules, actually, because what we do, if we know, if we're finding a bunch of numbers, say we've got some numbers, like I'm going to make up some heights, actually, that's probably a good way to do it. So I'm going to make up some heights of some people in a class. Might be a bunch of year 10 students or something like this. And their heights are, I'm going to make them up, 158 centimeters, 164 centimeters, 147 centimeters, 161 centimeters, 199 centimeters, 155 centimeters, 163 centimeters, and I'll have one more, 170. So you look at these numbers and you go, okay, and then you think, oh, hang on a bit, this one's a bit big. This is bigger than I expected. I mean, if you look at all the others, what do they go from? They go from 147 up to probably this last one here, 170. And then we've got this one which is miles and miles away. So I suppose the question is, what do you do about it? Is it definitely an outlier? And what do you do about it? So those are the two things we've got to ask ourselves. Because this might be, for instance, it might be the case. I actually wrote it down wrong. It wasn't 199 at all. You might think of your class that you just measured, and you thought there was no one who was, that's almost like 6'8" or something, and there was no one who was that tall. So perhaps it was 149, 159. I just wrote it down wrong. Perhaps there was someone in your class who was that tall, in which case, again, you deal with it in a different way. You might ignore the data and say, no, that was wrong. Or you might say, no, actually, it was right. And I do need to include it. So I was going to talk about this because this is what we do. It might be easier if I do this on the next slide. And we have two rules for determining whether or not a number is an outlier. And this rule number one says an outlier is more than 1.5 times the interquartile range past the nearest quartile. So let me just give you a brief example of this in numbers. Let's imagine I do some sums. My minimum value equals 20. My maximum value, I'm going to say, is 84. And my median, it's completely made up this, but you'll see what's going on from it. So my median is 45. My lower quartile and my upper quartile, let's make some numbers up for these. So this is going to be now going to be 30, and this is going to be 52. And if I do this, obviously I can then calculate my interquartile range. My interquartile range is actually just these numbers, one take away the other. So 52 take away 30, I reckon there's 22. Now, let's see what it says. It says an outlier is more than 1.5 times the interquartile range past the nearest quartile. So by that I mean I've got my nearest quartile, my 20 is possibly a problem. So I say to myself, how far is 20 away from 30? So if I draw a picture of this, this is a standard looking box plot, which I'm making up. My lowest value is 20 and my lower quartile is at 30. So you can see that's 10 away. My interquartile range. So if I wanted to know if this was an outlier, I'd go, well, my outliers would be beyond this point. So I'm going to go 30. I'm going to minus, because it says this 1.5, 1.5 times 22. Now 1.5 times 22 is quite easy to do. It's 33. So that would be 30 minus 33, which is negative 3. Have I got any numbers lower than negative 3? And the answer is no. My lowest number was 20. So that's fine. So this is good. I've got no outliers at the bottom end. What about 84? Now 84 seems further away to me. 84. Let's just have a think about that. So at the top end, what was my number? It was 52. And to be an outlier, you have to be 52 plus 1.5 times 22. I just said that's 33. So it's 52 plus 33. Oh, look at that. By pure fluke, it was really close to being an outlier, but not quite. See, 84, if it had been a little bit further, an 85, I would have said it's an outlier. But nope. Therefore, that perhaps shows you what I mean by definition of an outlier. And then there's this second rule that says an outlier will be more than 2 standard deviations away. And we have this second rule because sometimes you find the mean and the standard deviation rather than the interquartile range and the quartile. So just bear in mind that you have to use the right rule depending on what kind of data you have. So let's make it up. Let's imagine I do a sample and my x bar, my mean, is 56. And I find my standard deviation, sigma x equals 9. Now, what would be a definition of an outlier then? So you just, here's 56 in the middle. And basically, I add on 2 times that 9. 2 9s are 18. So if I add on that, I get 74. And if I take away 2 lots of that, I minus 2 times 9, that's minus 18. And that would give me, what would it give me? 18 off that would be, it sounds like 38. So if I had numbers bigger than 74 or less than 38, I would say, I think I've got an outlier. And if they're not, they're not. Well, let's have a look at some questions. That's probably the best way. And I'm going to keep on putting this rule up every time we do some questions. So look, I need to find the median and the quartiles for this data. That's my first job. So how many numbers have I got? 1, 2, 3, for both sets of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got 11 women. So if I have 11 women, the sixth one, 1, 2, 3, 4, 5, 6. That will be my median. So for the women, the median equals 33. Now I could just type these into my calculator as well. There'd be no problem with that. If you want to do that and just do it in your calculator, feel free to do that. And then from there, I reckon that is the middle of those 5 numbers. 1, 2, 1, 2, and I've got that in the middle. So I've got 24 as my lower quartile, and above that number I've got 1, 2, that one. So I reckon that one is my up quartile. And so straight away you see I've got an interquartile range between the two is 20. And I do that same rule that I just did. I do 30. So I do at the bottom end, I do 24 minus 1.5 times 20. And 1.5 times 20 is 30. So that's minus 6 when I do that. Have I got any number smaller than minus 6? No, I haven't. This is a matter of time they spend working or something like that. So it's definitely not a negative number. At the top end, the upper quartile is 44. So I do the same thing. Plus 1.5 times the interquartile range. Now that's 30 again, that's 74. Do I have any numbers more than 74? No, I don't. 67 is my highest number. So for the men, no outliers. What about them? Sorry, that was the women. What about the men? So I do the same thing. I need my median, and I need my lower quartile, my upper quartile, and my interquartile range. Notice at the moment I'm only using that rule 1 because this is a question about median and interquartile range and stuff. So anyway, how many numbers I've got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. I've got 20 numbers. So I want these in between the 10th and the 11th. 1, 2, 6, 7, 8, 9, 10. It's there. So I can quite easily say my median then is 33. And ignoring this, I can then split my numbers 1, 2, 3, 4, 5. It's there. So again, there's no exact place. So I reckon 25. Hopefully you get the same answers if you're doing this on the calculator. 1, 2, 3, 4, 5. I reckon there. And so that is 41.5 for the upper quartile. And that gives me a interquartile range of 16.5. So what do? Well, I take my lower quartile, which is 25, and I minus 1.5 times 16.5. I'm going to have to do it on my calculator. So I've typed that in, I get 0.25, is that right? I think I've tapped it in right. So I'm going to write 0.25. So it wasn't negative at all, it was positive. And the other one is I've got to go to the 41.5, and I have to add on 1.5 times 16.5. So again, I'm going to type that in. And I get 66.25. Now, do I have any numbers which are outliers? At the bottom end, my lowest number is 11, so that's fine. At the top end, oh look, I've got a 69. That is So I can write here 69 is greater than 66.25, and therefore this is an outlier. And that's what you've got to do. So that's the first. Yeah, that's the first example of one that we've seen using this first rule. Let's just check the proper answers. There is an outlier. They've got the same as me here. 66.25, there was one at the top end. So we've got a second one. I don't know what I've got a big white square there for, but it says the mean and standard deviation of the workers of this factory. That's what we want to do. So again, you should know how to type this in. We did something similar on a recent video. So I'm going to go menu 6, and one variable, and you have to have the 2 columns set up. So hopefully you've got that. So 10, 16, 20, and 145 in my first column. And then my frequencies, which I type in, I get 20, 14, 4, and 1. So I can just now press the option button and 3 on my class whiz, and I get these numbers. So I get X bar, my mean, is 16.6. And my standard deviation is, according to me, 21.1. So what's that mean? Identifying the outliers. Well, first of all, I've got to do then 16.6 minus 2 times 21.1. Now I'm going to do it even though I know it's negative. That's how much how these people are earning. So to be an outlier at the bottom end, you'd have to be earning negative money again. So it's minus 25.6. So I would still show that. But if I do at the top end, 16.6 plus 2 times 21.1. So let's just do that exactly the same. I've changed it to a plus. I think I've done it right. 58.8. Does anyone earn more than 58.8? Is this in thousands of pounds or something? Doesn't really say, does it? Yeah. Looks like the company boss is an outlier. Someone in this company earns £145,000. So yes, he is definitely an outlier. Should the data be cleaned? Yes, it probably should. It's not given a fair reflection of the average salary of the people working in that firm. What did my answers say? I agreed with those. And then again, I've identified this outlier. So third example now, it says, well, I'm not going to do this now because it involves me having to draw a graph. It says, that's lucky, doesn't it? It says, by drawing a graph, it was found that these things were true. Are there any outliers? Well, that's lucky because I don't have to do much work here. So I can find the interquartile range. That's my first job. I was panicking for a bit. I was thinking I was going to have to draw a graph, which I wasn't keen on. And I reckon that is 8.8 when you take those away. Now that tells me interquartile range is 8.8. And again, you go to the lower quartile and you minus 1.5 times it. Remember, this is back to rule 1 because it's all about quartiles and stuff. Times by the 8.8. Now this is definitely negative. I'll do this on my calculator. 4.8 minus 1.5 times 8.8 minus 8.4. Do we have any people aged less than 8.4 years old? No, I don't think we do. But then we go to the upper quartile, which is 13.6, and we add on 1.5 times 8.8. So 13.6 was the upper quartile times by 1.5 times 8.8, and again you write your answer down. Yeah, and I get 26.8 here. Do we have any people older than 26.8? No, I don't think we do. So I think at both the top end and the bottom end, we have no outliers. What's my say here? No outliers between, because they were between, all were between these two endpoints. So notice I identified these endpoints and therefore said all these children were between these ages. I've got one more example. I'm going to save this till class. Anyone who's doing this from home, you might want to do this for yourself. And we've got this, basically this summary of cleaning the data, and you might want to read that. And other than that, we're going to do exercise 16E in class. Anyone, again, doing it from home, they're the questions I would pick out as being ones which are appropriate for you to practice your A-level maths skills on. So this is Outliers and Cleansing Data, and I hope that was useful. All the best.